Alright, so let's look at integration by parts. This will be my fourth example. I'm doing one problem per video. So integration by parts, we got u and v are differentiable functions. So the integral of u dv is equal to u times v minus the integral of v du. And we want to let dv equal the more complicated function, provided that there's an integration rule for it. Okay, because we want to be able to integrate it. Alright, so let's look at the fourth example. We've got x squared sine x dx. So in this case, what are we going to let dv equal? Okay, we're going to let it be sine x. Okay, because that's the more complicated one, and we know, and there's an integration rule for sine x. All right, so I'm gonna let dv equal sine x dx, and so that means v is the integral of sine x dx. And I forgot my equal sign. So this is going to be negative cosine x. Alright. And so u is going to be the other one, the x squared. And so that means du is equal to 2x dx. Alright, so let's plug everything in. Let's write our formula down. So we've got u dv is equal to u times v minus the integral of v du. Okay, so we've got x squared sine x dx is equal to u, which is x squared, times v, and v is negative cosine x, minus the integral of v, which is negative cosine x, times du, which in this case is 2x dx. Alright, so let's just go ahead and just rewrite this, kind of clean it up a little bit. So I get negative x cosine x, and then the minus, I'll bring that out, so that'll be plus. And then I've got the integral of 2x cosine x dx. Alright, so looking at what we have here, if you look at this right here, we can't integrate this because of the x here. So we have to do integration by parts a second time, just on this part right here. Alright, so what I'm going to do is I'm just going to take this and I'm going to just simplify it. I'm not gonna write this. I'm gonna wait, and I'm gonna use integration by parts on this, and then I'll combine whatever I get for this and this. Okay, so all I'm going to do now is I'm going to look at this part. How about we do it in blue? Alright, so what am I going to let dv equal? Well, I'm going to let dv equal I'm going to let dv equal cosine x dx. So that means v is equal to the integral of cosine x dx, which is sine x. And so u is going to be 2x. And so that means du is equal to 2 dx. Alright, so let's write our formula down. So I get u dv is equal to u times v minus v du. Alright, so let's plug everything in. Alright, so I've got 2x cosine x dx is equal to u times v, 2x times sine x minus the integral of v, which is sine x, times du, which is 2 dx. I'm going to just go ahead and write the 2 dx like this. Okay. Now we've got 2x sine x minus, and then I can integrate this. So the antiderivative of sine x, okay, I'm going to get 2, and the antiderivative of sine x is negative cosine x plus c. Okay. And so this is going to be 2x sine x, and then the minus and the minus, that's plus 2 cosine x plus c. Alright, so now what I'm wanting to do is I want to combine this result and this result. I'm sorry. And this result. Okay. The negative x cosine x and the 2x sine x plus 2 cosine x plus c. Alright, so that means that my final answer, the integral of x squared sine x dx, is equal to the negative x squared cosine x, which is this part right here. Okay, and then notice it's plus whatever I got here. So plus this, okay, because that's what this equals. That's 2x sine x plus 2 cosine x, and then I'm running out of room here, plus c. And this would be my final answer. And I hope this video has helped, and I hope you'll check out my other videos. Thanks.